Welcome to Study Loop.
Once again, welcome to a new problem. This time we have three pucks. We have three pucks. They sit on a table. It's a horizontal table, so we're going to call this one puck A, puck B, and puck C. And then what's going to happen is that um, there's going to be movement. They're held together before they're released, and each one of them has the same speed, v. So speed of each puck is v, and so this puck moves westwards in the negative direction. We can have an axis like this. So this is y, and this is the x direction. This is positive, and that's positive. So that's what we're given. And they have a repelling magnet. So each one of these pucks has a repelling magnet. So they're repelling each other. So we want to know, like, this is the information that's given. So we want to know what's going to happen to puck B and A when we release C to the west, to this side. Okay, so when we release C to the west, we want to know what's going to happen to puck A and B. That's the question we have right now. So it's a fairly abstract problem requiring us to kind of like use momentum. So the first thing we're going to do is we need to find the direction. Okay, our goal is to find the direction that A and B are going to go. So the first thing is to use the law of conservation. Conservation of momentum, which says that the initial momentum is going to be equal to the final momentum. So P initial equals to P final. But remember, the pucks are not moving. So that means P initial is 0, and that's going to be equal to P final. So they're all 0. To get the momentum of the system, so the total momentum of the system is the sum of the momentum of each one. So we're summing them up. So P momentum of A plus momentum of B plus momentum of C has to be 0. But remember, momentum is mass times velocity. So velocity of A, velocity of B, and velocity of C equals to 0. We can divide everything by m, and that's going to cancel out these m's, all of these. And so in the next page we have a new relationship that says velocity of A plus velocity of B plus velocity of C equals to 0. And that just means that we can always rewrite this to have a new equation. But before we do that, remember we said that if we're going east, that's positive x, and then if we're going upwards, that's positive y, that's not. Using this equation, we can see that we can rewrite this in terms of unit vectors. So we write in terms of unit vectors. So we're saying velocity of ax plus velocity of this should be ay, sorry. So velocity of ax and velocity of ay. Ax I hat in terms of unit vectors, ay g hat. We do the same thing for the b velocity of b. So we split the velocity of b into unit vectors, and that's very valid. And then we also split the velocity of c into unit vectors, like that. And that's all of that is going to equal 0. And then we group them. We say, let's put all the I vectors together. We want to put all the I vectors together, combining them. And then we want to put all the j vectors together. So we're combining them. J hat, that's equals to 0. And so this simply means that if you add two things and their value is 0, it means that either this one is going to be 0 or that expression is going to be 0. So then we say Vax plus Vbx plus Vcx equals to 0. And also we do the same thing here. Vay plus Vby plus Vcy equals to 0. Remember, so on the next page, remember we had three parks. This was A, B, and C, and then the C went westwards. So if you think about Vcx and Vcy, Vcx has to be 0 meters per second. Sorry, Vcy has to be 0 meters per second because it's only moving westwards. Vcx obviously is going to be the same as the velocity but in the negative direction, and then Vcx is 0 meters per second, and Vcx Vcy is 0 meters per second. Vcx is negative v. So this is Vcx, which is negative v. That's the only component. Vcy obviously has to be 0 meters per second. And so, going back and looking at this equation, we know that Vcx is 0, so that's going to give us a new equation of Ax and Bx being equals to 0. So Vax plus Vbx equals to 0. And also in terms of the y's, we know obviously Vcy is 0. And they told us that the two Vay and Vby, those two are going to equal 0. So first of all, if you see that Vcx is negative v. So we have to change this. So Vcx is negative v. So we have Vax plus Vbx plus Vcx equals to 0. But this one is v, so that changes that to 0. And so Vax plus Vbx equals to v. And then also we have this part, ay, by, and cy. Remember, Vcy is 0. So when we take Vay plus VBY plus VCY, that's equals to 0. But remember, VCY is 0, so this is 0. And so we're left with VAY plus VBY equals to 0. That just means that VAY equals to negative VBY. So these are the component velocities for X and Y. And then something else happened. We got to see that the X components of A and B are the same. Okay, the X components of A and B are the same. So in terms of the Y component, these two are going to have the same magnitude, different direction, but the same magnitude in the X component. So since VA and VB have the same magnitude in the Y, then they will have the same magnitude in the X. So by magnitude, we just mean that this portion of the equation is the same. The direction is different. That's the vector part, but the magnitude part is the same. So that simply means that VAX has to equal VBX, and that's equal to the component of the velocity Vx. And so, if both of them are the same, we can use this logic to solve this problem by saying Vx plus Vx equals to V, and on the next page we simplify that by saying 2Vx equals to V, so Vx, which is the component of the total velocity, is V over 2. And that helps us compute the directions, because remember, we have the x direction and we also have the y direction. And so if you have a velocity v, it has a x component vx and y component vy. This is theta. So it means that cosine of theta has to be vx over v. So theta has to be cosine inverse of Vx over V. But then remember, Vx is V over 2, so this is cosine inverse of V over 2 over V, which is just to say the V's cancel. So this is like saying the cosine inverse of 1/2. And that's going to give us 60 degrees. It's going to give us 60 degrees. So in terms of the components, if you go back and look at pack A and B, you can see that they have opposite directions. So they're moving in opposite directions. And so that simply means that one of them is going to go that way, and then the other one is going to go that way. So this is north, this is south, this is east, this is west. So this is 60 degrees, and this one is also 60 degrees. So we'll say pack A, this is pack A, and this is pack B. Pack A moves 60 degrees north of east, and then pack B moves 60 degrees south of east. So that's what we have in this problem. Hope you enjoyed it. We had 3 packs and they all had the same momentum. the initial momentum was 0, that helped us come up with an equation that would compare all the velocities and make them equal to 0. And then we change that to unit vectors. That helped us cancel out some of the velocities. And so if we look at for pack C, it was only moving westward, so the velocity in the y was 0, but in the x it was negative v. So we came up with a new equation, which is this one, simplifying, making the previous I hat expression being equal to v, because we replaced vx by negative v. And then we did the same thing for the yvc. Y was 0 because the path going to the west doesn't have a y component. And so we're left with vay and vby being equal to 0. And so it shows us that the path A and B are moving in opposite directions, but they have the same magnitude. So they'll have also the same magnitude in the x, and that's going to be the vx component of the velocity. And then finally, we're able to show that 2vx equals to v, and the reason for that is you're replacing vx for these two right here. This is vx and that's vx, so we simplify and come up with a different way of expressing vx in terms of v. That helps us to compute the cosine of theta in terms of vx over v. We replace vx by v over 2, and then that's cosine inverse of 1/2. That gives us 60. Hope you enjoyed the problem. Feel free to ask any questions and have a wonderful day.